Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is out of trend, that is OOT, and out of expectation, that is OOE. While testing the input materials for manufacture of pharmaceutical products, the test results may fall out of routine expected values. Though they are not considered as out of specifications and they are within specification limits, they are considered as out of trend or out of expectation. Let us understand how these OOT and OOE are identified and monitored for defining correct kappa. Out of trend OOT. Out of trend is defined as a result of a sequence of the analytical result that conforms to the specifications but not in the expected trend with respect to the initial or expected result. Here the word trend should be understood well. When the data is plotted, it shows a definite pattern in the data points. For example, the SA of a product is between 98% and 100%. Generally, you may get a value around 99.5% for many data points. But suddenly, there could be some values occasionally around 98%. This is within the conformance specifications, but it is not within the regular pattern. Similarly, you have another example in related substances or organic impurities, especially obtained in HPLC analysis within a limit of not more than 1%. The routine pattern may be around 0.4% and 0.5%. But suddenly, when there are results around 0.7% or 0.8%, the pattern drifted away from the routine pattern. This is the meaning of out of trend. OOT results, though within the specification limits, show an unexpected trend that could indicate a potential problem if not addressed. So, if there is a sudden change in the trend, there is likely to have adverse impact on the coming up batches or coming up results. This trend will indicate whether the process is under control or not. Out of expectation, OOE. It is an unexpected value among the analytical results recorded for a short period of time. OOE is defined as a parameter value which lies outside the expected variation of the analytical procedure with respect to either location or dispersion. It is defined as a parameter value which lies outside the expected variation of the analytical procedure variation. During the analytical method validation, it is important to evaluate the variation and relative standard deviation to establish how much the values could vary. Test results that meet required standards but are unusual or unexpected compared to typical outcomes. The OOE values may meet the specification limits, but they fall beyond the established variants of the analytical method validation. Let us see how the OOT is identified. Make a X bar control chart. Average chart or X bar chart is one of the most popular control chart for determining the OOT. Identify zones for plus or minus 1 sigma, that is zone C, plus or minus 2 sigma, that is zone B, and plus or minus 3 sigma, that is zone A, with central line CL, upper control limit UCL, and lower control limit LCL. While developing the X bar control chart, these parameters are derived. There is a separate video training program titled X bar chart and R chart that was posted about 6 months ago in my channel Pharma World. You may please refer for more details. There are 4 basic rules that can help establishing whether or not the data is OOT. There are 8 more rules in addition to these 4. Initially, these 4 rules may be adopted. Rule 1. Any single data point is outside the 3 sigma value from central line. That means any data point beyond zone A on either side of the UCL or LCL is considered as OOT. Simple graphical example for this rule 1 is given in the upcoming slide. Rule 2. 2 out of 3 consecutive data points are beyond 2 sigma. That means in zone A or beyond on the same side of the central line, below or above the central line. Rule 3. 4 out of 5 consecutive data points fall beyond 1 sigma in zone B or beyond on the same side of the central line, below or above the central line. Rule 4 is 9 consecutive data points fall on the same side of the central line, that is zone C or beyond, below or above the central line. These are the remaining rules 2, 3 and 4. The examples for these rules are also given in the coming up slides. In this, one point is beyond zone A on UCL side and LCL side. Example for rule 2. These 2 are out of 3 consecutive data points beyond 2 sigma in this example for rule 2. Example for rule 3. 4 out of 5 are in zone B and beyond. This rule, for example, 9 consecutive points are on the same side of the central line. Out of expectation over E. Over E is not a statistically reducible value from a database in contrast to OOT. As you can see from the above examples, OOT is derived from a series of data points, whereas OOE is a variation in the expected result as established by the analytical method validation. It is an expectation based on some evidence on what would be the most likely outcome of the analytical process performed. This excludes any unusual result derived from analyzing a sample with a totally unknown assay or content of the analyte in question. When the test result does not fit into the other results of that series, it is considered as over E. There is enough evidence and information allowing to anticipate the expected result and thus to allow judgment that the result does not represent the expectation. This is a statistical variability, that is range and or RST among the replicates. So this is important point while carrying out the analytical method validation. These two variability parameters must be taken care of during the method validation. Let us see the evaluation part. The UCL and LCL provide a range of what is still acceptable for a result. These can serve as control limits for over T and over E. These are important and useful statistical tools available for data evaluation to establish over T and over E. UCL and LCL will be still under the specification limits. Q-sum plot is helpful in spotting a biased process. Q-sum is short form for cumulative sums. In detecting small but persistent departure from the target or predefined value, this Q-sum chart is more appropriate. Moving range control charts of two consecutive observations is used as an estimation of process variability that is very useful for detecting over E. Exponentially weighted moving average EWMA chart also works like Q-sum plot. Process capability indices CP CPK values will provide great deal of information on the data trends. Typically, values for CP of 0.5 or 1 indicate that the process is not capable to produce consistent quality product. CPK values 1.33 and 1.67 indicate for a capable process, and more than 2 it indicates a highly capable process. P chart for control for fraction non-conforming, C chart and U chart control charts for number of non-conforming, or a few other controlling strategy for establishing the data if it is out of trend or out of expectation. I hope that this brief information on OOT and OOE is useful. Try to understand the intent of these tools and get the best results out of it. Thanks for watching. For more videos, please do subscribe, like and share. Also, please leave a message in the comments box for any further support. Thank you.